My name is David Watkins. I'm with Up and Farms. Welcome to our video podcast series. Today we are with Delaney Johnson, and we are going to be discussing the exciting topic of conservation pest management. Is that correct?
That's correct.
That's correct. All right, and you have a background and experience that will allow us to cover this in detail. Is that right?
Yes, that's correct. I have a background that, first of all, consists of a Bachelor of Science degree in soil science and a master's degree in agronomy, and with agricultural sciences as my background.
So what I'm hearing from that is that you spend a lot of time in the dirt, or a lot of time in the books.
Soil.
We call it soil in the biz, not the dirt.
That's it. That's life giving. It's the dynamics of the origin of life, and soil is the basic fundamental building block for everything that's in existence.
So I'm gonna infer from that if we're not paying attention to our soil, if we're not really taking care of it properly, then what we'll have is dirt.
That's correct. Dirt is displaced soil, or soil that is not functional in the way it should be as a living, dynamic, natural system.
Wow, I was just kind of playing around, but you had a real technical response. Dirt is actually something really specific. It's
a living system.
Okay.
It's composed of organic and inorganic materials that make up the matrix for soil. And the sand, silt, and clay components are the inorganic parts. And the microbial and the organic matter is the living part. And in combination, that makes a good medium for plant growth.
Gotcha. All right. So about what percentage of that soil is organic and what percentage might be inorganic?
The organic part is probably pretty much 5%, and the inorganic is pretty much 40%, and the other 40% consists of water and air.
All right, so we're almost half water and air.
Right.
Right, and about 45%, something like that, inorganic matter. So when we're talking about soil and the living organisms within it, it's that 5% that makes all the difference.
5%, that organic matter, that 5% is what makes the difference to us as in the agriculture community.
Okay, all right, and that it's that organic matter that really paves the way within the soil for the plants to be able to root and grow and get their nutrients from the soil. Is that right?
That's correct. It's organic matter which makes organic carbon. Organic carbon is what drives the biological community. That's where they get their energy in order to generate nutrients that make it available for plant uptake.
Okay. And if we deprive our soil of those, the organic matter within it, then the consequences of that will be
low fertility.
Okay. Low fertility in the plants.
Low fertility in the soil.
In the soil. Okay.
Soil.
Okay.
And by that meaning low fertility as far as plant availability to have access to nutrients. And that makes equals a low yield and poor crop performance.
Okay. Okay. So I guess it's it's pretty easy to maintain that soil, right? You just kind of let it go. You don't have to do anything with it, and it'll kind of take care of itself.
Well, we would like, in theory, that's the way it would be, but man has manipulated the soil to the extent and just depleted the natural conditions of the soil. Then it has to have some help to get it restored back to its natural fertile conditions.
Okay.
And that consists of several practices that we have recommend that we have able now to install, apply on the farm operations on the ground in order to restore the soil back to its natural fertility condition.
Is part of the factor, the equation in that the specific crop that you're growing as well?
We try to make it irrespective of crops.
Okay.
But we try to look at the soil as a medium itself and try to increase the fertility by increasing the biological community, which we said first, increasing the carbon content, because carbon is the energy source that the microorganisms rely on in order to have their energy to produce and function as they would in the soil.
So this biological community, I mean, that's actually a pretty big phrase, right? It's a biological community. It sounds like a group of organisms are getting together and kind of having a part. Are we talking about, 10, 20 organisms? How many organisms make up this community?
Several billion organisms can make up 1 square inch of soil, 1 square clod of soil.
Several billion.
Billions.
Wow.
In that size of a soil material.
Wow. That's a very small but enormously large community. It's almost incomprehensible.
Comprehensible. And they interact and they go on to generate and behave in their natural environment, which consists of the soil, inorganic material, the organic matter, and also water and air, in order for them to thrive in that type of habitat, in that community, in that soil medium.
So within the soil, I'm thinking, I'm walking over this. It's just like it's land. I'm thinking land. But you're saying within that there's air and
Correct.
There's water, like
Correct.
Just kind of naturally underneath our feet.
Yes, correct. In the air, what we call air, there are pore spaces in the soil, and that's what we encourage farmers and producers to make sure you have good aeration in your soil, because those are where the air pockets exist. Also, we have what water. Oftentimes, it's not liquid water, but it's gravitational capillary water. It's attached to the soil particles. Therefore, the plant's roots and the microbes can extract that moisture from the soil particles in order to have moisture that is available to them.
Okay. All right. So capillary water. So this is so what I understand from what you were just saying is that this form of water plays a role
Right.
in helping the plant roots actually access nutrients from the soil.
Right.
How does that happen?
Well, capillary water is not free water. It's water that has some tension. And in order for any roots to extract water from the soil particles, it has to have some type of tension that exists in order for it to intercept and be able to extract that moisture. Also, the microbes are able to extract that moisture also, because it's capillary water. If it was saturated, if it was free water, then it will be flooded or saturated. Then it will be under a different condition. It will be aerobic, which is oxygen depleted. All the air pockets we talked about at first would be filled with water, and that would make the soil saturated or flooded, and that would be a bad environment for the microbes and plant roots, because it would be in a flooded state.
So, when you're talking about tension, so are you talking about electrical charge?
Not electrical charge in this sense, but tension as far as absorption, ability to extract water from suction is the tension component, the suction that it would take in order for that to take place. The roots removing moisture from the soil particles. That would be a suction type apparatus that would be occurring at that time. Not electrical. That's another subject.
Okay, all right. Well, it sounds like we're delving into both physics and biology as well as chemistry.
It's all of that.
All of that kind of coming together, and this little community of every square inch is a couple of billion organisms. Now, those types of organisms or total organisms?
Well, they are like protozoa, nematode. Those are microbes that you can see under the microscope. It takes microscope to see these.
Okay.
And then you have larger ones that are also present in the soil itself. So You have anything from millimicrons that you have to look at them through a photon telescope, or the larger ones you can see them through a regular microscope. But in any sense, they are not seen by the naked eye. They
Okay.
have to be seen through a microscope.
So we need some assistance to see these.
Right.
I can imagine there are a couple of billion in a square inch. They must be pretty small.
Pretty small.
So when we're talking about just land and nature and soil, there's all different kinds of soil. Is that right?
That's correct. That's
depending
correct.
on where you are in the country and the world.
That's correct. Well, let me first phrase it. There's no such thing as a bad soil.
Okay.
All soils are for some use or purpose. All soil have their own suitability. But as you said, there are 9 or 12 different soil orders that we have recognized throughout the world.
Okay.
And the soil orders are at the highest level. But then it goes to soil order, suborder, subgroup, great group, and on down into the family, and on down to what we call series. That's what we use as the nomenclature for what we identify difference in soils or throughout the landscape here in the world. We have a classification system.
Okay.
But we name them because they have certain inherent properties that are unique to itself, distinguished by color, distinguished by texture, distinguished by elevation, distinguished by climate, distinguished by physiographic regions, distinguished by pH, distinguished by mineralogy, which different types of clay minerals can occur in different soils throughout the landscape. So it's several different variables where we use to distinguish one soil from another. But each individual soil that we have named has its own inherent features and characteristics. And everything we do as far as the use of soil is for use and suitability. We base it on how it is to be used or what it's not suited to be used for.
Gotcha. So each of these soils, they have natural, as you described, each of them has their own kind of natural characteristics to them that make them more or less suitable, not right or wrong, just more or less suitable to do certain things and to grow certain things in them. And I'm guessing that there are things that we can do to manipulate the soil to a certain degree to make it more adaptable to do certain things or other things. And sometimes we may manipulate it so much that we break the system in it.
That's correct. That's correct. Yeah, and that's one of the things that man has a habit of manipulating things to the extent that is no longer recognizable of its original features and characteristics. And what we encourage is using the soil according to its suitability, its natural suitability, and try to use it in according to what it lends itself to. If a soil is on steep areas or steep hilly relief, then it's not suited for such as croplands for agriculture. It may be suited for more or less a permanent type cover, like grazing land or forest land, woodlands. So that's one of the basic things that you have to give account for as far as an agriculture community. Or if it's too sandy, or if it's too clay, it has its own inherent limitations. Or if it's concave on the surface shape versus convex, then there are certain uses and suitabilities that soil area will lend itself to. So what we try to do is recommend the use of soil and soil types based upon its suitability, and not manipulate to the extent where it's unrecognizable. Once it's unrecognizable and is manipulated to that extent, then it's lost its inherent features and abilities to function as it did before it was altered.
Okay. And then you have to spend a lot of time and money mitigating that and trying to get it back to a more natural state.
Right.
Okay. All right. So you a couple of times you said we in that, and what I'm hearing the we from is this the we from your years of experience as working within RCS?
That's included in that we family. We family is everybody, every society, every mankind category. Farmers, producers, landowners, developers, um, engineers, scientists, educators, um, any type of utility use of that land resource, then that's the we're talking about.
Okay.
Everybody has a responsibility.
Okay.
We are just the ones that help guide and coach and direct what is suitable or what's not suitable or what's recommended or not recommended. But every human being on this earth has a responsibility to be a good steward of our soil and water resources.
Excellent. Excellent. I wish everybody knew that. So, how did you get into soil science? How did you get into this to begin with?
Well, that's interesting, David. I grew up on a truck crop farm. My father was a truck crop farmer. That's a specialty crop farm as we know it today. And we had some small patches and gardens of vegetable crops. We had swine, we had cattle, we had chickens, we had all the different things you would look on the farm. And I grew up not recognizing that I like that type of interaction with life, whether it's animals, whether it's plants, whether it's outdoors, or something that deal with life. Mm-hmm. And I went on to graduate from high school in Haynesville, Alabama, Haynesville High School. And I went on to college at Alabama A&M University. And the professor that recruited me, he was a soil scientist. He was soil microbiologist. And, I was impressed with him, and that's what I said I wanted to major in. And from that point, I was signed up to take the curriculum for soil science degree. And from that point on, I was able to get summer employment as a student trainee in different locations in the state of Alabama. And with that, I became more motivated and say, this is a career, this is something I like doing, because it's inside and outside.
Right.
You're interacting with nature. You out alone by yourself, and you just look at, see the birds, hear the birds, and hear the wildlife and stuff. And that really motivated me. I was like, you can make a living out of this. This is a career. And 40 years later, that's where we are.
That's what, and helping other people make careers out of that.
That's right.
So when you're young, when you're a preteen or a teenager, and you're on the farm, I guess you're doing the daily activities, you're participating in the farm.
Right.
Is that right? What kind of mindset does it take to engage like that, and how does that experience inform you in your current day?
Yeah, nature is always telling you something. You're learning something from nature. Even the insects, the butterflies, the bees, the earthworms, the snails that crawl, the other larger species that you see on a daily basis, birds. You see them interact, and then they have their own habit. They have their own routine about the day. And you look at it, you study them, and then you just become a part of that life, that environment. And what it does is instill in you to care for those creatures, because also you see predatory. You see a frog eating a bug, or you see a snake has caught a bird. You see all those different things, and as you grow up in life in the rural and the country, and you take an appreciation for that. You don't understand why, but it caused you to be inquisitive and curious. And I thought that was part of my nature, and I wanted to just. It seemed like it was something that I fit. That's where I fit, and I just find out I was just blessed to be able to go on and get an education in that area. That it had with nature, landscapes, landforms, wildlife habitat, and that whole community, and it just became a part of who I am today.
So you really began with an appreciation of observation, just seeing the environment on the farm, and the animals and the different species interacting with each other.
Right.
And your love of that, you're being drawn into that, you're being curious about that, really kind of led you into understanding more about things you can't really observe with the
Right.
naked eye, such as the life that's taking place in soil.
Right. That's it.
An endless curiosity led you from the observable to the unobservable.
Unobservable. That's a good way to put it. Yeah. And also, it just gives you that appreciation for just knowing that there's something above you that you can't really describe. You really don't understand, but you keep trying because of your curiosity. And that's the science in it. And that's what will always give me that motivation, that enthusiasm to just be out with nature all the time as much as I can, to just try to still understand it and appreciate it, because it's always giving back. You're always learning something from nature. Just the way the wildlife carry on their routine about the day. They are smart creatures, and they do it by habit, and they continue, and they are faithful and they are loyal in what they do. And we take them for granted, but they are about the business, and we try to understand them more. And the more we understand them, the more we probably will be able to understand ourselves.
Well, it sounds like within there's a good balance in there between not just the science and the quest for understanding and knowledge, but also maybe philosophy in there.
Yes, philosophy. Yes,
which is the love of wisdom.
Yes.
And those two things kind of existing side by side.
Side by side. That's it.
Maybe that farm environment, the being out there and to a degree of solitude, it invites a contemplativeness.
It does. It does. It invites. It's therapeutic, and you could look at nature, and then you can relate to it, because you know that animals, they have that in that nature. They don't have the discernment to have reason. They do it by instinct. And we look at that as something that is a subordinate to our way of thinking. But at the same time, it's looking at and studying. That's wisdom that has been installed in them to function and carry on our existence, that we can observe and take advantage of if it's really looked at and studied. Right.
So, what similarities do you see then between that more observable world and the more unobservable world, the world that you have to parse through and really kind of study and connect the dots between? How are those worlds really related?
Yes, and most of the things that you can see with the naked eye is everything except that. So you have to look at what is not there most of the times. And with that, you see and understand how nature works and how it behaves, and you know that it's climatic. We'll use for an example the climate conditions. It's changing, and then we see where the vegetation is responding to our climate change and conditions. We see where vegetation is dying, is wilting. We see where large vegetation such as trees are self-limiting themselves because they're trying to survive. But it's things that you have an awareness for, you're seeing it, but you look at to understand the reason, the cause of the reason for why things are having that type of behavior in reaction towards nature and climate. And once we understand those two components, you have a reaction. For every action, there's a reaction. And we understand that what's causing this, and that's what causes us as scientists to distinguish ourselves from a novice, because we've always wanted to understand why this is happening.
So maybe when we start to see abnormal reactions, then that gives us pause and makes us want to think, well, what has changed in this environment? What's changed in the ecosystem here for the action that's causing this reaction?
Right.
And maybe it's something that's been introduced to this from outside.
Right. And it's man-induced. Man is responsible for a lot of the things that is happening on the earth today. And we look at the carbon concern. We know that plants take in carbon dioxide, and they use it for growth and photosynthesis and development. And it dispels it into the ground where the microbes take advantage of it because it's something that they use as energy. So, and that's why we encourage year-round conservation, year-round cover, year-round great live plants roots in the ground that the microbes can have access to that energy in order to keep them active, that they can generate nutrients and manufacture or convert them into compounds that will be used for plant uptake in that cycle. So everything is cyclic, and we look at that particular aspect as something that man can help. Man can help be steward over as far as how the world and the compounds in nature behave and how they are used and how they are used in a beneficial way in order for nature to function in a healthy way that we can be healthy people. Air quality, water quality. We looking at water quantity. We looking at all these different things. Resource concerns. And we have 4 resource concerns here in the state of Mississippi: air quality, water quality, wildlife habitat, and erosion control. Okay, but you take all those pieces and you take them into context. Which one is the most critical and most, I guess, essential? Is the water, because we hear that anything in existence, even in our outer space existence, in research and studies, exploration, we see, well, if it has water, then it has life. So we take that to account. So if we can manage our water resources, which is a resource that concerns all of us as citizens. So that is one of our main priorities and charges, is to manage our soil and water conservation and resources. And here at Up in Farms, I think that's what we really encourage and just motivated to do.
It's, as you're saying that, I was thinking about priorities, and USDA obviously has a certain set of priorities that are about conservation. We at Up in Farms have adopted a lot of those priorities of our own.
Right.
I think in time we have, as humans, have had conflicting or competing priorities. Sometimes they're very, very immediate priorities, such as just feeding ourselves,
right,
having enough calories to feed ourselves, so that we don't experience hunger as a culture or as a community.
Right.
Other times, maybe we're prioritizing just the speed, the haste of getting things done, and you prioritizing the accumulation of money through some of our practices that are really about making short-term decisions. And you talk about man-made interactions with the land.
Right.
We've been making a lot of short-term decisions over a long period of time in
Right.
some cases, where this could have unforeseen consequences about our water quality and the water quality,
Right.
Quantity and quality available
Right.
to us, and our air quality.
Right. And we look at that as step up to the plate as being one of our primary responsibilities, because in order for us to be healthy, we have to look at those basic essentials of nature. And in order to have healthy crops, because we have to eat. One thing about us as a human race, we have to have some type of energy, and that energy does not come from what we talked about earlier. The carbon, we can't extract pure carbon and be able to thrive. We have to have it broken down, but carbon is that essential energy source that we talked about. The microbes take in and utilize that in order to generate nitrogen and other essential nutrients that make it available to the plants that we eat in order to not survive as a human race. So we got to look at that connection, because we think it just food just happens and we see it on the tables and we take it for granted. but we have to back up and look at how things begin and where does it originate. And we keep that healthy. One primary, I always pounce on, is the soil. You keep the soil healthy, it'll keep you healthy.
It's what's interesting, or at least to me, one of the things that's really interesting about that is we as humans need certain nutrients to survive.
Right.
And we think that we're eating plants, in that sense, but but plants are the ones who are actually absorbing nutrients, and they're the ones who are transforming that, because we can't intake some of those nutrients directly.
Right.
So they're doing work for us.
Right.
And gathering that together so that we can then consume them.
That's correct. That's correct. And it encompasses just a whole combination of nutrients that we could not be able to package ourselves. Nature has a way of doing that for us, and we kind of neglect that way of understanding and appreciation that that's what nature's already doing for us. Now, we as higher class species, animals, then we have to cook, we have to prepare our vegetables and food and fiber before we eat it, and for energy, for energy in our consumption. But in the wild and wildlife, as we talked about earlier, then they eat raw forage, raw fiber, food, grass, everything, and they have to eat more of it because the digestion process begins once they eat it. But with us as human beings, we cook our food and prepare it so the nutrients are already more or less accessible to our systems, that we do not have to eat as much in consumption. So that in that context, you look at that we are lucky to be in the area where we can understand the dynamics of food and the necessity for nutrients, protein, all these things, even our livestock, that is protein. Our vegetables and crops are fiber. Okay, so food and fiber. We are herbivores, not omnivores. Well, we partake of food of plants and animals. Okay, so looking at it from that context, and we have to be good stewards of the land, good stewards of the grasses, of the food and fiber and forage, because we have the luxury to take all of that into consumption to for us to live as a human race.
When in this day and age, when we think technology, or when we hear the word technology, I think the first thing that's come to mind are like my phone or my computer, or even a car.
Yeah.
But really, the most basic form of technology is cooking, is food preparation. We found use technology, develop things to help extract those nutrients, to make them more available to us,
right,
more accessible to us directly, as humans in our consumption, to get that energy.
Right.
Yeah, that's our most basic technology right there.
Basic technology, and it is a technology, and it is a chemistry. Mm-hmm. So mixing of different types of foods and for flavors and different textures, and you put it together and make it palatable, make it something that you could sit down and eat a whole plate of, because it's deals with our taste buds, our able to palatable to chew it and be able to taste the differences in the flavors and stuff. So that is something that we have unique to us, because in wildlife they just have to chuck it down, but we are able to process it and make it something more enjoyable to eat. We eat oftentimes a lot of times for just luxury or pleasure, But in the wild, they have to eat for for life, eat for
Right.
survival. You know?
Their instincts are kicking in and saying, hungry.
Hungry.
Let's eat. Let's eat.
That's
Yeah.
it. So that's how we in the agriculture community have to have our special appreciation for the farmers and growers and producers that they have spend their time producing and making sure those crops are good and tasty before it gets to our tables.
So, changing the subject just a little bit, we've talked about, well, it's really, I think, I really appreciate hearing your background and how you got into this and your mindset and the way you approach this. Because I assume that informs a lot of the way you work with developing certain clientele, the type of people you want to work with, and the type of information you want to relay to them.
Right.
I think we've been pretty fortunate in this process over the last 6 months or so to work on a few different types of really in-depth training,
Right.
looking at nutrient management, looking at soil, micro irrigation. We're working on high tunnels and some other kinds of NRCS practices. Really doing a little bit of a deep dive on these things to help make them more understandable and relatable to people who can use them.
Right.
I think one of the most complicated issues to me is really this concept of pest management and the relationship between pest management and crop rotations and cover cropping and these things, and just understanding what the principles are behind this.
Right.
And the infinite variability in it too. But how does this exist as a concept?
Yes, we know that everything that's good, it has a downside. Okay, you can go out and your best day, your best effort can be detrimental to you and your efforts of whatever project you're working on. And in this case, we are talking about growing crops and growing our food and fiber. Okay, so we're going to have some negative impacts. And we know that we live in nature. We live in a system where we have millions and millions of different species of different types. And everything is looking for survival. Everything is trying to survive. And when we grow our crops, we look at agriculture as a agriculture. It's a cultivated species that we're trying to grow in a place that is foreign to it. And we're trying to sustain it as a plant that we hope to grow up and germinate and grow and be able to harvest that fruit produce from it at some point in time. But that life cycle, in order for it to germinate from a seed and all the way up to planting and growth and development and providing fruit and food and fiber and vegetables, then it goes through a lot of different changes. There's a lot of different things that are working against it. Climate, heat, temperature, sunlight, no rain, drought, too much rain, wetness. Also, we're looking at the insects part about it. Insects, pests that thrive on these vegetations because it's foreign, it's green, it looks like it's nutritious, it's attracted to them, and you have all type of insects that want this for their food also. Okay, on that journey life cycle for that crop to grow up to maturity, then we as farmers, as producers, have to tend to them because we said earlier, it's a culture. It's grown in a place that is foreign and it's out of place. It don't have any protection, natural protection. So we as looking at it as husbandry and nursery people to help that plant grow to maturity that it can be a produce for us, fruit for us at some point in time. But on that way there, we have to deal with pests and insects because they are just trying to live too. They're trying to survive too. That's their way they produce. That's the way they multiply. That's the way they survive. Through eating and they find nourishment. We find the same thing. They don't mean any harm, but they just want to survive also. But we look at it as a negative aspect. Because pests are harmful, pests are bad things, pests are bad. They're just trying to make a meal also. So we have to look at that aspect. But at the same time, we have to manage and have appreciation for them. And at that case, can't everyone survive? Even we know that as a human race, we have deaths we hear about all the time. But at the same time, we have to manage that population. So we have to find controls because oftentimes there are no controls as we had thought about in the past. But now studies have come to find out where there are different types of pest control and pest management systems. One is biological, trying to find out the type of predatory prey scenario where you have some insects there prey on the other ones. So you don't want to remove those predatory insects because they are preying on another insect that might be eating your food and your vegetables, crops and stuff, your crops. So we want to try to understand that dynamic. We also have what we have done in the past is chemical controls, where we just spray and kill everything. So we don't know. First of all, you have to identify what pests or what insects are there present in order to treat that particular insect and not try to just mass spray and you really not benefit anything because you really expenses of using application of fertilizers or chemicals. They're really not doing any good at all because you're not targeting the insect or pest that you're trying to remove from your system. And we have mechanical, we have cutting, and we have burning, and we have all different types of pest management systems. And also we have another one we have is the selection or cultural type of pest management control, where we look at the timing and the breeding, of the incubation, of the larva stages, of the maturity, of pupae stages in insects and stuff, and we can find those time intervals in plant species that they are subject to outside of that growing cycle for those insects, and that's one way of the biological control and also cultural control. So we've come a long ways, David, in the way we understand pest management. And what we just talked about then, we look at the chemical, we look at biological, we look at mechanical, and we look at the cultural components. All those together combined, that kind of is called integrated pest management.
Okay. So integrated pest management. Just to reinforce what you said, we're talking about some different types of controls: a biological, mechanical, chemical, and cultural.
Right.
These are 4 different kinds of controls that we can apply in there in an integrated approach. So we're not just, for example, relying on chemicals. Right. So one of the interesting things that I heard you say in there was, and there were many interesting things. That was a lot. One of the really interesting things I heard you say in there was, just talking about pests in the way we have, the way we use that word in our language has become a very, it has an extremely negative connotation to it. Yeah, that person's a pest, or they're a pest. They're pestering me, But really, what we're talking about is another organism that likes the same food source that we like.
That's it.
So they are actually just natural competitors with us.
That's it.
We're competing for the same energy source.
That's it.
Right, and it's what they do. It's what they're targeted. It's how the nature has helped evolve them, so that is they want the same thing that we want.
That's it.
But there are other things out there that might eat them.
Right.
It's like the way nature continuously works is it does have that kind of pyramid. It does have that kind of thing where one thing that preys on something else is a food source for another organism.
That's it.
And I think what we have come to realize over time and through study and observation is that when we're doing broad pesticides, when we're doing just broad eradication, then we can actually end up removing predators
Beneficial.
that, or what we call beneficial organisms. They're not beneficial to the prey, they're not beneficial to the pests, those pests, but they're beneficial to us, or preserving the crop, so that by eliminating or disrupting our competitors for that food source.
That's it. And we don't want to, not looking forward to integrate, eradicate, but we're looking to manage. When we use the word manage, that's what we need to put emphasis on it. Not eradicate, not become extinct, because we don't want to remove them down to 100% where they no longer exist in nature, because they're here for a reason. Okay, but if we don't understand the reason they're here, so we have to just take that for granted. They're here for a purpose, a reason. With that being said, the management part is the balance of, can I remove these insects or pests long enough in order for my crop to mature and harvest? And you want to manage that balance, because you're not going to spend every penny of your earnings trying to remove every single beetle or every single ladybug from the planet of the earth. Okay, so what you want to do is find that balance in managing that pest population that is affecting your crop, that it will not cause you to suffer a loss in that cropping season. So that is the management part, because when we say management, it's a financial factor in that also. And
there's something I was reading about earlier about the potato beetle, and the potato beetle would be a pest for some of the common nightshades like tomatoes and eggplants. And one way of managing this is if you're doing a number of plantings of those nightshades within a season, then you need to have a distance of at least 650 feet. And if you have that distance of 650 feet between your plantings, what you're really doing is creating space that pest, once that crop that it's been feeding on goes away and it's looking for a new source, it has to travel a long distance to get to this new food source. And by going at least 650 feet away, then what's happening is that by the time it gets there, it will basically cut out 1 to 2 weeks of time. It'll basically put the timeline down, push that down 1 to 2 weeks, so that it doesn't disrupt the harvesting of those crops. That they don't get there in time to do that damage. It delays. I guess I should say it delays the damage that they would cause because of the distance they have to travel to get there.
Right.
And so some of the cultural practices and some of the biological practices, that could be part of an integrated program might be, digging trenches or other things, putting in crops, in between cover crops or grasses.
Right.
That have certain kinds of smells that repel, the pests, that move them in a different direction, put them off the scent, or make them have to work harder to get there. Right. Is that a way of saying that?
That makes good sense, and that's a real good practice in order to install, because it's well thought, because it's cost efficient. You're not actually installing anything. You're not really spending any expenses. You just creating space, creating distance from one crop to another, or one crop planting to another. And what you're trying to do is make it harder for those insects to travel from one distance to another. And in the meantime, like in human nature, in psychology, Well, it's so far, I'm just not gonna make that trip. I'm just gonna stick with the field I'm in. I'm not gonna try to travel that distance. But in the meantime, the one to do is a farther distance, and in that time distance, then that crop that they're trying to make it to is maturing and developing, and probably the stage when it gets to the stage that it can probably have a more of defense that is grown to a size that is no longer susceptible to those insects. So that's a good practice to install also.
Okay. Okay. And that's just an example, of one pest that might be for one type of crop that may be 650 feet. For other types, it may be half a mile or a mile that you need to. It could be greater distances that you need in order to really make a substantial difference in that. And I guess time would be another real factor in that, where this is where you might follow a crop with a cover crop or another cover crop, and then a different type of crop, and do such a sequence.
Right.
So that you eventually come back to that crop.
Right.
But it may be a year, or it may be 3 or 4 years before you return a crop to a same space.
Right. And by that, you're right. And by that time, you look at that insect population may have gone on, or it may have died off in that area. So you will have eliminated that pest or that species from that area for that amount of time, just because you did a crop rotation, a crop sequencing that would deter make it non-attractive for those particular insects that were present there at that time.
Because those larvae can continue to reside in the soil, and some of them have an incubation period of
Right.
years before they emerge.
Right. Yeah. Insects and weeds, weed seeds, they both have can reside in the soil for years, and especially plant seeds, weed seeds, and you till it, you disturb the ground, and next thing you know, you have another population of those weeds that you thought you had removed some years ago. So therefore, what we recommend is try to understand what weed it is and try to focus on treating that particular species, and not, like you say, this mass broad application and stuff.
Wow. So when we're thinking about crop rotations like that and a strategy for them, it really is about managing over a longer period of time, managing pests, but not just pests, also weeds and disease, while you're also putting in a sequence that improves the soil fertility itself.
That's correct. And that's a good point, because we know that anywhere you have a healthy species, healthy soils, healthy animals, whatever the case may be, they are less susceptible to disease. They are less susceptible to sickness and vulnerability. They're less vulnerable. So what we try to do is promote soil health. Well, we call it soil health because you have fertile soils, you have fertile fertility. In itself is going to reduce, suppress some of the weeds, some of the insects that will prevail in a certain area. Okay, and once your crops get to a certain size, you got to look at also the health and vigor that deters sickness, disease, because once a plant becomes diseased, then that is sense of a pheromone where you have insects, they sense that, and they go to those plants and stuff, and they just devour them. So if you have a healthy system, what we encourage is a healthy whole system. The soil, the water quality, the nutrient cycling ability, the right mix of pH, soil chemistry, what we talked about earlier, all those different components help to remove or help to eliminate or minimize the impacts of potential disease and infestations and all those different things that are negative to a good healthy program.
I see a, a, a similarity between the plants and us, and like
Right.
it's like our immune system.
Mm-hmm.
If we're not taking care of ourselves, if we're not eating right or getting enough exercise, or not sleeping at all, our immune system is going to get worn down, and it's going to make us more susceptible to illness, to sickness.
Yes, sir.
Otherwise, we have these natural abilities within our body to fight off, the things that would harm us.
Right.
These plants are the same way.
Same way.
They've got natural immune systems in there that when they're hardy, when they're getting the nutrients that they require from the soil,
Right.
then they are more robust and more able to repel those insects and disease. This is without any chemical, support from that, other than things you might add to the through fertilizer, through soil amendments. But these are when you're taking care of your plants that way, they have maybe not 100% ability to ward off any insects or pests, but they certainly have the ability to protect themselves.
Right. Bounce back and not succumb to those insect infestations. Right.
So that's it. It's fascinating. It's interesting. It's in that cycle of a crop rotation sequence, where at the same time as you are deterring certain pests, through time, deterring disease, you're also building up the fertility of the soil and the organic matter within that too, that will make your plants healthier when you come back to them in the rotation.
That's great. Because you have multiple organisms, microbes in the soil that are attracted to certain types of plant species in the roots. So therefore, the more diversity you have above ground, the more diversity you're going to have below ground. And that makes for a more healthier environment, because you're looking at systems where you have each one building up a certain tolerance for their surrounding. And the more diversity you have, the more able it is to find resistance to multiple types of would-be types of infestations or diseases. So the more diversity is our key piece in forest pest management, crop rotation, crop production, all these different things. Diversity.
Okay. Wow. There are some really specific practices that NRCS, Natural Resource Conservation Service, within USDA, will contract with farmers for as well, that are part of an overall approach for pest management, but disease management. And really it's, I guess, that and part of a nutrient management program kind of together. When you're looking at some of these practices, could you help illuminate what some of those practices might be, and what they are and how they kind of work together?
Yes, we have our pest management systems where we utilize and help install or apply those practices we provide. NRCS provides assistance, financial and technical assistance, to help producers install or apply these practices for pest management, and also for different types of crops, the species that would help reduce that concern. Then it's into the guidelines that we have posted, and it's available to the producers. It's available to us as advisors to the producers, that would help alleviate and bring the information of knowledge and information to those farmers and producers, in order for them to be better and more efficient and they're successful in that program.
So help me understand this. I think I'm on the right path here, but help me understand. There are practices such as conservation, crop rotation, and conservation cover. Some practices like that, but there are also practices such as filter, strip, and field border and critical area plantings. And these are all places where you can plant different kinds of grasses and legumes and cover crops and other things like that. They could be designed to incorporate those kinds of cover, non-cash. Right. When we say cover crops, we're talking about non-cash crops. Right. That they could all grow in there, but they can be programmed as well so that they will attract beneficial insects. That support beneficial insects or pollinators that support the other cash crops that you're growing. Right. Adjacent to those or alongside those.
That's correct. And what you just described is above ground, and also you've got to look at the below ground effects also from these plantings. And it's based on the proximity of your area, of your farming or cropping area. Then you would identify those zones where you may not grow a crop, non-cropping zones. That's where you would introduce some type of grass cover or some type of good rooting system species that would help filter help offset the off-farm runoff or release of different types of pollutants or different types of chemicals from getting off site and on into our streams and our waterways and causing another problem, off-site problems and stuff. So
this to me is the most. It's the fascinating thing. It's also I guess maybe the complicating thing in this, in that you need to think through it. It needs to be planned, But when you're working with a practice that is designed to treat an underlying resource concern, such as sheet or wind erosion or rill erosion, something like that, or salt seeps, other issues like that you might get within a field border or something. Right. So NRCS is engineering these practices from the perspective of they're designed to really prevent those things from happening. However, if you plan them right, you can design them such that they provide, a central cover or beneficial qualities, for
right.
your cash crops.
Right.
It just does take. Right. That happens by intention.
Intention. There has to be some planning piece that takes place on the front end, and the primary focus or mission of NRCS is to prevent things from happening in the first place, to prevent erosion, to prevent runoff, to prevent contamination. So those are the practices. That's the primary intent. But now once they are released, or once the prevention part is out of the box, then you have those corrective measures that we have, programs that we recommend those practices be put in place. But the primary objective for us as advisors and providing assistance to farmers and producers is to maintain and stabilize what's already there, keep that in place. And then you develop your building block of soil fertility, soil stability, and aeration, then creating good rooting depths, rooting zones and stuff that would help reduce or minimize the impacts that would be negative to the plants, but at the same time maintaining the soil medium in place. And what we talk about, those measures that prevent runoff, preventing inundation because of the ground may be too wet or somewhat. Then we have measures where some areas are not suitable for certain practices. Some areas are not suitable for certain crops. So we would recommend that these crops be planted, no crops be planted here. This might serve as a reservoir for pollination species or something that would still be beneficial to the overall program, agricultural cropping program, but at the same time, it's not physically or directly producing a crop commodity, but it's serving a purpose. It's serving a purpose. And these, as far as trying to put some cover on these non-planting zones that are not really prime land to crop, but at the same time, they're there, so it needs to be a purpose that it can be used in order to minimize the overall effect of what we talked about first is water quality, water quantity, air quality, and the whole environmental habitat. So you got to look at the whole farming, and not just the crops that you're going to put in the rows, but the perimeters, the interior components, the strips down the rows, and what stays wet too long does not be able. It's not suitable for farming, cropping. Then it may be suitable for some other type of practice. So that's what we try to identify in the farm plan, utilizing the land resource area, maximizing its use based upon its suitability for that particular use.
I think I find that utterly fascinating, and we come into contact with a lot of farmers, do workshops and other events, and it never ceases to amaze me the number of farmers that come to us and who say, I want to grow organic, or I want to grow all natural. Yeah, I want to do this. They really are approaching things, not necessarily from a complete knowledge base, not necessarily from understanding the chemistry of that, but from wanting an outcome that is, to me, what I hear them communicating is, I don't want to introduce a whole bunch of, artificial things into the land, and into my body, and so I think that there's an audience here that really would adapt to these practices, but there's a little bit of barrier in communicating what the different practices are and how to understand it, and maybe what farmers really need to understand first is that starting point. You need the starting point of understanding your land.
Land, good land, good soil management program, and good soil fertility, increasing your organic carbon level, and all these things. Then you are already doing it organically because you are minimizing the need for commercial amendments. You minimize the need for pesticides and herbicides. If you have a good comprehensive integrated pest management program, soil health program, and you are doing organic farming without the rules and regulations and stipulations of what is required to be an organic farmer. You're already doing those things. So that's what we have to make our producers realize. If you adopt these practices, you're already on a strong road to organic, the organic concept of without the stipulations and the regulations and stuff.
Yeah, I think that what goes along with that is just understanding what your farm, what your land wants to grow, and not necessarily what you want it to grow. But this goes back to me what you were talking about in your youth, and what led you into this to begin with, is that the experience on the farm, in the environment, observing nature. observing the different species interacting with each other.
Right. That's it.
Yeah.
And I think the observation, you hit the nail on the head. Understanding and studying, that's observation is studying. You're picking up on the what ifs of if I harvested this, if I cut these row of vegetables down and I left them standing and it formed a residue on the surface, then I have a little mulch right there already. So you just observing.
And the residue is what's left.
It's what's left.
Okay.
Yeah. And you're looking at all those different things that is happening, but you hadn't put it into context of what's going on. So once you understand those dynamics in an operation, this on-site observation, you're going to pick up on a lot of information that's going to benefit you from season to season, from one growing season to the next, because you're learning on what not to do and what worked and what did not work. And the other piece is recording. Write down what you saw. Write down what you observed. Make a little note in order that you have something to reference back to. Because our human minds, sometimes they forgetful. So you want to write it down somewhere, and you can reference it, and you can look back at what you did 3 years ago, 2 years ago. So that's one of the other good practices to adopt as far as any type of good farm management.
Yeah, I think especially in this era where we got access to phones, that have cameras on them. It's when you're documenting things, you are your own scientist.
Yeah.
People need to be their own scientists, and they need to document. You need to document what are you doing,
right?
What are you doing, but also what am I seeing?
Yeah.
What's normal? And the only way you know what's normal is if this is something that's happening over a period of time. This
right.
continues to happen. Well, that's normal. And then by noting that, observing that these are the things I'm seeing, you're likely then to observe what's abnormal.
Right.
And then you can start getting into that cause and effect. Well, something abnormal is here. Mm-hmm. What has caused that? Have I introduced something? Has something else happened to introduce this? Right. Or is it time, that's introduced it? And so what are ways that we can then figure out what it is, and then, have a different cause and effect,
That's it. Yeah, and like I say, it may be totally different from your first original thought of what caused that problem and stuff. So, like I say, it's observation and being able to understand what's happening. And one of the best way to tell a story is you eyewitness it yourself. That's the best story you can tell. That's what I saw with my own eyes. And you capture that, and you know what happened. It's not like you had to read it somewhere. It has a certain appeal, a certain, place as far as your mind storage. It's something that's kept in your mind, and you are able to build upon that because you saw it happen. So that's what we, as our producers and farmers, we want to encourage. Kind of just you already doing what you hope to do, but you just haven't realized it. So oftentimes we want to highlight and just work with them and bring out that part of what they're already doing and highlight. I know I used to watch The Wizard of Oz on TV, and that show came on every year.
Yeah,
I used to watch it. And everyone wanted to go to the wizard or something. When they got there, they found out they already had what they were looking for.
That's right. That's
it. So
that's right.
So you just have to try to help capitalize on that. A lot of resources that have not been tapped into because we don't know it exists. But oftentimes it's right there.
Yeah, I think that's one of the most important things about record keeping, and that people don't really necessarily understand is I think a lot of people think of it as a burden, as something that's as a requirement, something that they're being asked to do or being told to do, and they don't necessarily see the benefit of it.
Right.
The on the other hand, them every decision that's made, if you were going to go to a consultant, you're going to go to somebody to say, help me understand what's happening here. The first thing they're going to say is, well, show me a picture. What do you see?
Right.
And then what have you done?
Right.
But what they're also really going to want to know is, what did you do before this?
Right.
And what did you do in the year before this? And what are you doing adjacent to these things? What have you seen? Those are the kinds of things that if you actually want good interventions,
Right.
Then you need good information.
Right. That's it. You need some good information.
Yeah, and people who are just there to help you, they can only provide the quality of the help they provide is only going to be as good as the inputs you give them.
That's it.
Yeah.
That's it.
Yeah.
Yep.
All right. Well, I think that's a wrap for today. We have a lot more presentations to do and a lot more conversations sitting in front of us.
That's it.
But this has been really great. Is there, in closing, is there anything else you want to add to the context of this, or?
I think it was a great conversation, great discussion, and dialogue. But I would like to add that agriculture is never ending. It's always something that we're learning. It's still in the infancy stages of agriculture. And we also have a situation on our hands now where agriculture is going to play a major role in the climate change, climate smart efforts, because it's all based upon the ground, and we are the experts of the ground and growing and production. And we are far ahead of the rest of the group as far as understanding the whole dynamics of agriculture and environmental systems. So I think what we have started here, I think it has just continuous room to grow and develop, and it's all learning. It's all because we'll never get where we expect to be as far as experts. The only expert is the one that keeps learning. That's
right. That's right. Well, the sheer fact of life is that we don't always see the waves of evolution right in front of us, because sometimes that happens over years or decades, centuries, millennia. Yeah, but sometimes we do see those things happen, and we have to adapt with them.
Yeah.
We have to adapt our practices, and then there are things where it's not just natural changes that are happening. There's a lot that we have induced by our practices as human beings that are putting stresses on the planet, and we need to find some ways to counteract that.
That's it.
Yeah. Well, let's do it by growing well and eating well.
That's it. That's where it starts. Because if you don't do those two pieces, then you won't be around. So it won't do you any good anyway. Because so we have to maintain our existence here as a human race, and in order to do that, to stay healthy.
Then let's start by doing that.
That's
All right. Thank you. I appreciate it. Yeah.
Okay.
Yeah. Okay.